Hi, this is Rob. Welcome to this video in the Docker Tutorials playlist on the Cumulus Cycles channel, where we'll discuss Docker Compose. Up to this point in the series, we've created single containers from single images. With Docker Compose, we can define and run multi-container Docker applications. With Docker Compose, you define your application services in YAML. Then, with a single command, you can create and start all the services from your configuration. Using Compose is basically a three-step process. First, you define your application's environment with a Docker file. Then, you define the services that make up your application in a file named dockercompose.yaml. And third, you run the Docker Compose up command to start and run your multi-container application. In this video, we'll be utilizing the Docker Voting app application to work with Docker Compose. The source for this example can be obtained from the Docker Samples GitHub repository. And there are two ways that you can get this code. First, if you have Git installed on your machine, you can clone the repo. Or you could download the code in a zip file. Then extract the file and view the contents. Now, the voting app is a sample application that allows a user to cast their vote between cats and dogs on a web page and then view the results of their vote on another web page. And it's implemented using multi-containers running as services and interacting with one another. So in this diagram, we can see the layout of the application. There's a container for the voting application web app written in Python, which interacts with another container which is running redis for caching. There's a worker container with an application written in .NET, which interacts with the redis container and a container running the POSTGRES database. And finally, there's another container for a Node.js web application which displays the results of the vote. Now, before we dive into Docker Compose, we'll take a look at the application source code to understand how it's put together. Then we'll stand this application up manually, which will really give us an appreciation for working with Docker Compose later. So here in VS Code, we see that we have several files and folders in the app source. But I'm going to clean this up just a little bit so we only focus on the files and folders we need to run the app. Alright, that's better. So we have a Docker Compose YAML file, which we'll hold off on looking at right now. But we're interested in these three folders. One for the voting app, one for the worker app, and one for the result app. Now, if you remember looking at the diagram, we said that there were 5 applications, each running in its own container, that we need for this application to work. Now, the voting app application has its source code in the vote folder, and it has a Docker file. The worker app has its source code in the worker folder, and this has a Docker file as well. And the result app has its code and Docker file in the result folder. So we have the source code and the Docker files for the voting app, the worker app, and the result app. But what about the Redis and DB containers? These images are available on Docker Hub. So we'll just pull those images and use them to spin up containers. The custom applications, we need to use the Docker file to build the images that we could then use to create the containers. If we go into the Vote folder and look at the Docker file, we can see that this image will be built from the Python 3.9 image. They run some commands to do some updates and installs. They change the working directory to the /app folder, copy some local requirements, and then do an installation. Ultimately, they expose this application running on port 80 in the container. The worker app is built from a Microsoft container because it's a .NET application, and the result app from a Node image. And ultimately, this application is also exposed on port 80 in its container. Now, if we take a little deeper dive into the code itself, in the voting application's app.py file, we see that there's a getRedis function that's pointing to a host with a name of Redis. And that's the connection for this voting application running in its container to connect to and interact with the application running in the Redis container. Going back to the diagram and looking at the worker container, we see that it needs to interact with both the Redis container and the Postgres database container. So if you jump into the code for the worker app, we see that it's connecting to Redis and connecting to DB. Now these are the names that we'll give the containers when we spin them up. And in the result application server.js file, we see that it's trying to connect to the Postgres database at the host DB, which is the DB container. Okay, so now that we know how this application is defined and understand the connections between the application containers, let's go ahead and spin this app up manually. Okay, so looking at the application diagram, we need to start with the voting application. So let's jump over to the terminal in the vote folder where the Docker file lives. And we need to build an image for this application. So we'll execute the docker build command, passing a tag of voting app and then the dot to indicate that the Docker file is in the current folder. So let's go ahead and run this. And if we do a docker image ls, now we see our voting app image. And now we should be able to use the voting app image to create a container where we'll expose the port 3000 on the local machine to the port 80 where the web app is running inside the container. So let's go ahead and create that container. And now the container's up, we should be able to jump over to the web browser and go to localhost 3000 and we see our applications running. Now, if I want to click on one of these to vote, we see I get an internal server error. And this is because, remember the application integration, there's a connection between the voting app, which we just saw in the browser, to the Redis container. And first of all, we don't have the Redis container up and running, so we'll do that next. But we also need to provide a link between the two containers so that the voting app running in this container can interact with the Redis app running in this container. So let's jump over to the command prompt and do that. So first, I'll exit this container with Control-C, and if we do a docker container ls-a, we'll see our exited container. Now I'm going to go ahead and clean this up now, because after we start Redis, we'll have to come back here and restart this container, and I want to use the same name. Okay, and if we check, now we don't have any containers. So let's jump over in a new tag, and we'll execute the docker container run command to create a Redis container that we'll name Redis. Okay, so this container is up and running. So let's jump back over to the tab where we have our voting app. And now we want to run an instance of the voting app container. But this time, as I indicated earlier, we need to establish a link between the voting app container and the Redis container. And we'll do that by using --link and specifying Redis on the client and Redis in the container. So let's go ahead and run this. And if we go back and reload our page, now we see we have our voting app with the one vote for cats. Okay, so now we have our Redis container running and our voting app container running, and the voting app is linked to the Redis container. Now we're going to stand up the worker container, which also needs a link to Redis and a link to the Postgres database container. So before we stand up the worker, let's stand up the Postgres database. And I'll do that using docker run, giving this a name of DB, and we'll use the 9.4 tagged image of Postgres. And the reason I'm using 9.4 is because that's what the Docker voting app demo uses. So let's go ahead and spin up this container. And if I spell container right again, we should be able to get this to work. We're close. It actually did pull the image down that it needed to start the container, but it's telling us that we have an error because we need to set the Postgres password parameter for the application to be able to connect to the Postgres database. And the way that we're going to do this is by using the -e flag to pass an environment variable in with the Postgres password. So before I could do that, I need to delete the container which just terminated because I want to use the same name. So I'll go ahead and remove the container, clear the screen, and this time we'll pass the Postgres password environment variable in and set it equal to Postgres. So let's go ahead and run this. Okay, so now our Postgres container is running, which means that now we have Redis and Postgres up. We could go ahead and start our worker. But before we can start a container, we need to go ahead and build the image from the Docker file. So let's go ahead and run this command. And if we do a docker image ls, we see our new image. And now we could go ahead and spin up a container. So here, we're going to execute docker container run, where we're going to establish two links, one to Redis and one to the database. And we want to use the worker app image that we just created. So let's go ahead and launch this container. And you can see the application is up and running, and it actually connected to Redis, and it sees that we have 3 votes in there already. And that's because I was playing around with the web interface. So I'll show you what I mean. If I go back to the voting app, I can cast a vote for dogs this time. And if we go back to the container, we see a new vote of B. And if I go and vote for cats, we see a new vote for A. So now we're in pretty good shape. We have Redis and Postgres up and running. The voting app is linked to Redis, and the worker app is linked to both Redis and Postgres. So the last thing we need to do is spin up an instance of our result app. And of course, we'll need to build the image first. Do a docker image ls, and we see our result app image. And we'll spin up a container exposing port 3001 on the host mapped to port 80 on the container. We need to establish a link to the database container and use our result app image. And it says the app's running on port 80. And if we jump into our browser and access localhost 3001, which is mapped to port 80 on the results container, we see the results of our vote. Okay, so now it's time to spin this application up using the Docker Compose YAML file. And to prepare for this, I've gone ahead and cleared out all the images and containers on my machine. And we're in the web app folder, which has the Docker Compose YAML file. If we jump over into VS Code, we can take a look at the file. So first, they specified the version of 3, which is the current version of Docker Compose. And then they've defined several services. Now, each of these services is a definition for a container that's needed to run the application. So if we expand the vote service, we see the first command it executes is to build the image using the Docker file in the vote folder. Then the command to execute is Python passing the Python application. And it's going to map port 3000 on localhost to port 80 in the container. For the Redis service, they're using the Redis Alpine image and exposing this port. The worker builds the worker image using the Docker file in the worker folder. For the DB, they're using the Postgres 9.4 image and setting environment variables for Postgres user and Postgres password set to the default Postgres. And finally, for result, they're building the image using the Docker file in the result folder. The command to execute is nodemon, starting the server.js node server, and they're mapping port 3001 on the host to port 80 in the container. Now, to kick this whole thing off, we execute the Docker Compose up command, and it will go out and pull the images. It'll build our local images. It will spin up the containers with the appropriate links between them. And then we should be able to go to localhost 3000 and load the voting web app, and then 3001 and load the results. So just wait for this to finish. And it looks like we're connected to the database. So if we jump over to the web browser, we'll start with localhost 3001, which is the results page. And there's equal percentages because there are no votes yet. So let's load localhost 3000 for the voting application, cast a vote for cats, and then go back to the results. And we see that there's one vote and cats have 100% of the votes. Now, I think you'll agree it was much simpler to spin this application up after the Docker files were created in the appropriate application folders, and then the Docker Compose YAML file was written to define the services versus going through the manual process that we did in the previous exercise. Well, that's a wrap for this Docker tutorial series. There's a lot more to Docker than what we covered here, such as volume mounts, Docker Swarm, and even Kubernetes, which is a container orchestration system. I'd encourage you to play around with the concepts we covered in this series before moving into these more advanced features of Docker. I hope you found this information useful, and I also hope to see you in another Cumulus Cycles tutorial series.